What if you could make your SQL queries much faster by using GPU? Presto is a large-scale SQL engine built to run analytical queries on CPU. But if you ever worked in large production systems, you've experienced that as your data grows, query execution speed can slow down. Thanks to work from IBM, NVIDIA, and others, the latest open source Presto can now run on GPU, giving you a major boost in performance. This is possible running Presto with Velox, which is C++ based rather than Java. In this video, I'm joined by William from NVIDIA, who built a use case in a notebook to show you how to set up Presto with both CPU and GPU, load a large dataset, run queries, and compare the speed across both setups. Thank you for joining us, William.
Hey, Roy, thanks for having me on. Thanks for letting me share this new Prestorial we created. If you go over to the Presto Foundation GitHub page, it's under the Prestorials repository here. But I've gone ahead and I've already cloned it. And let me just walk you through it real quick. There are 3 notebooks. They're really simple. The first one is going to stand up a Presto native cluster using Docker Compose, and it's going to operate on data on the host. And then the third notebook is going to show adding GPU acceleration to an existing data warehouse. The idea being you already have a data warehouse, you already have data local, and you're already querying the data, but let's speed up those queries with the GPU. So I'll just run through the first 2 notebooks and then show adding GPU acceleration. So the first notebook is going to create a metastore directory, a warehouse directory, and then the configuration for Presto. And then it's going to stand up the Docker cluster. And I have this cell in here to verify it's working. So we can see we have the CPU worker and the CPU coordinator, and they're both already running. Okay. Then a few simple queries to make sure it's up and running. And now in the second notebook, we're going to add more data. And the data set I'm going to use here is the IBM anti-money laundering data set. This is an open data set here in Kaggle. I believe it's also on Hugging Face. And it has around 176 million rows. If you grab the large data set, there's different scales. And this is going to do some queries, and I'm going to scroll down to the bottom of the second notebook and just again verify that it's running, and then run a few simple queries. And there we have it. All right. So at this point, we have a Presto native cluster running, and this is the notebook to add GPU acceleration. Notice over here in the Explorer window, we have our configuration, we have our data here, and the metadata for the warehouse. I'm going to go ahead and just create an exact copy of those configurations. Should show up here in a second. There we have it. So we have an exact copy of those configurations. I'm going to add a few properties for the GPU, and then we're going to start the GPU cluster. All right, that was pretty fast. So I have this thing here to make sure it's running. You can see it still says it's starting. I'll run this again, and it is up and running. All right, now I'm going to do a sample, just a select star limit 1. And I add this query in there to, again, it's a smoke test, but also the first query has to stand up the binaries in the VRAM of the GPU. So this one actually is going to take a second, and there, it's done. All right, now for the head-to-head, both queries, exact same query running on both the CPU and the GPU. So you can see I have this loop here, and I'm going to create a CPU connection in cursor and a GPU connection in cursor. Go ahead and set those up. And then this query, it's not a, terribly difficult query, but it does do a little grouping and a little sorting across all of those, and it's going to return 10 rows. And it's going to run that query against both of these CPU and GPU engines. Let's go ahead and run it. And I've also timed it. So the CPU query is running right now. It's going to take 6. All right, there it is, 6 seconds. And then the GPU one is 1.6 seconds. And I'll go ahead and close my connections. And so that is all it takes to set up a GPU engine on top of a CPU data warehouse.
Wow, that's amazing. Especially, it's great to see those performance updates. Can you tell me more about why GPU is performing so much better than CPU?
Yeah. This is so under the hood. This is using something we call NVIDIA cuDF or CUDA-X for data frames. And as you know, the GPU is really a parallelization engine. So a lot of these SQL operations are going to take a frame of data, and then we're going to join, we're going to aggregate, and then do some sort of calculation. All these things are optimized, run really well on the GPU. The bottleneck is it can take to load that data into the GPU. Some queries are going to be a little faster. If you have 100 rows, you're going to run that on CPU. But in this case, we have 179 million rows, and we did a little bit of a grouping and a sorting. So you can see it's 4 or 5 times faster. And so that's why the GPU will accelerate on a lot of queries versus the CPU.
That's great. And in order to set it up, you only had to make minimal changes in your Docker configuration, right?
Yeah, good point. Good point. I actually added this cell down here at the bottom to show the comparison. It looks better in the light, Jupyter light theme here. So yeah, good point. The left side of this is the Presto native CPU cluster, and on the right is the same thing, but GPU. And the main difference is, if you notice, our coordinator is Presto with the latest tag. And then this one is Presto, but GPU nightly. So we're grabbing the very latest version of this. And then for the worker, where you have one or more of these workers, you have the Presto native with the latest tag, and then the Presto native with the GPU nightly tag.
Awesome. And then why is the GPU side only set up as read-only?
Yeah, good catch. All right, so I did this intentionally. You don't have to do this, but I was thinking, if I already have a data warehouse and I have jobs running, I have reports running, I don't want to have 2 write operations corrupting the data. Obviously, you can change this. If you're just going to run the GPU engine, then you would remove that restriction.
Perfect. That makes a lot of sense. Thank you so much for joining us today, William.
Happy to be here.
In this video, you've learned how to use Presto with GPU to speed up your analytical queries against large datasets. You've set up a Presto instance in CPU, loaded a large dataset, run queries against it, and then did the same with GPU. And if you want to try out GPU-accelerated Presto yourself, let us know what you think about the performance updates you've seen right here in the comments.